Alright, let's look at the definition of definite integrals. Alright, so definite integral, so you have an integral sign, so this is an integral sign. Say goes from a to b of f of x and dx. Alright, so this is defined as just like the definition of area under the curve. But we don't have to assume that the function is always above the x-axis. So you could have a negative value out of this. So it's going to be a limit as n approaches infinity. Then you have a summation. I goes from 1 to n. Right? Then this is, so we can actually use left endpoint, right endpoint, or midpoint, or actually any point in between. So you have they use xi star. So xi star is a sample point on the interval from xi minus 1 to xi, and then delta x. All right. So here maybe I should say where xi star is any point in the interval from xi minus 1 to xi. So for example, if you take xi star to be xi minus 1, then this is basically the left sum. And if you take xi star to be just the same as xi, then this is going to be a right sum. And if you take xi star to be the average between xi minus 1 and xi, then it's going to be a midpoint rule. Right? But in this case, you don't have to specify. You can basically pick any number on that interval and call that xi star. Right? Then there's some terminology. So we have here this elongated s is called integral sign. So integral sign. Then for the definite integral, you would have a number here. This is called the lower limit of integration, so lower limit. And you could have guessed that the top number is called the upper limit of integration. All right. Then function inside is called integrand. So this guy is called, I'm going to pull it out, so integrand. All right, then this is defined just like the definition of area, and there's a name for this summation here. So summation here is called the Riemann Sum, and named after a German mathematician. So this is called the Riemann. Oh, maybe actually I misspelled his name. All right, it's actually Riemann Sum. All right, so this is the definition of definite integral, and you can think of it just like the area under the curve, but if the function curve goes below the x-axis, it turns out to be a negative value, right? But that for ease of notation, a lot of times instead of using a xi star, we're going to use xi. So we're going to basically use the right sum. And so since this is a limit, unfortunately, limit might not exist for some function. So this limit, if the limit exists, exists, then we call this function, f is called integrable on the interval from a to b, right? So integral basically means that you can find the definite integral, right? And to ease of notation, a lot of times when you actually compute definite integral using this definition, we almost always use the right sum, so that it looks like this. So everything is the same, and the summation I goes to n. Then instead of using xi, we're going to just use xi star. We use just xi, right? And times delta x, right? And where delta x is simply take the length of the interval, which is b minus a, and divide it into n equal pieces. And also xi is simply a plus I times delta x, right? So just a simple notation, a simpler notation to make the expression simple. So we tend to use the right sum, because if you want to use the midpoint, the expression gets complicated, and if you use the left endpoint, you have to adjust the indices a little bit. So this is the cleanest expression, right? But anyway, this is the definition of definite integral, right? That's it. I hope that this was clear.